Namaste students. So today we will be going to discuss the problem number 9 from the ISI MSTAT PSB 2024. The problem goes by this. Let y1, y2, y2n be IIT Bernoulli P random variables where P belongs to 0, 1 is unknown. Consider the estimators T1n equal to 1 by 2n minus 1 summation I equal to 1 to 2n minus 1 yi plus 1 and T of 2n equal to 1 by n summation I equal to 1 to n y of 2i minus 1 into y of 2i. So the first question is, so that both the estimators are consistent for p square, then find the limit in 10 to infinity variance of t1n by variance of t2n, and thirdly for large z, which estimator would you prefer and why? So now we know that y1, y2, y2n follows IIT Bernoulli P, where p belongs to 0, 1 is unknown. Next, we define zi equal to yi into yi plus 1. Now, we can write t1n equal to 1 by 2n minus 1 into z1 plus z3 plus order z2n minus 1 plus 1 by 2n minus 1 into z2 plus z4 plus order z2n minus 2. Now, why are we writing like this? This is the question. So, here the reason has been written that all the terms in Z1 plus Z2 plus Z2n minus 1 are IID and all of their mean exists. Similarly, for Z2 plus Z4 plus Z2n minus 1, all are IID and their mean exists. Now, expectation of Zi is expectation of yi into yi plus 1, which is equal to p square for all I from 1 to 2n minus 1. Now we can write this as this, just dividing and multiplying with n, and here just dividing and multiplying with n by n minus 1. So this, the first term converges in probability to half into expectation of z1, and this second term converges to half into expectation of z2 by the strong law of large numbers. And thus T1n is consistent for p square. Similarly, if we follow the same procedure, we will get that T2n also follows strong law of large numbers and is consistent for p square. Now for the second part, we need to find out the variances. So variance of zi equal to variance of yi into yi plus 1, which is equal to expectation of yi square into yi plus 1 square minus expectation of yi into yi plus 1 whole square. Now, expectation of yi equal to p and expectation of yi square equal to p again. Now, variance of zi is equal to p square minus p square of whole square, which is pretty easy to find. Next, we need to find out the covariance zi and zi plus 1, which is also again pretty easy to find. Just we write the formula and we get p cube into 1 minus p. Next, we need to find the variance of summation I equal to 1 to 2n minus 1 zi, which stands as summation I equal to 1 to 2n minus 1 variance of zi plus summation I1 less than equal to I not equal to j less than equal to 2n minus 1 covariance of zi, z. Now, here comes the interesting part. So, we will calculate how many covariance terms will be there. Covariance of z1, z2 is p cube into 1 minus p cube. But see that z1 has only correlation with z2. But z2 has correlation with both z1 and z3. So z2 has correlation with two terms. Similarly, till z2n minus 2, each of them has two covariance terms. But z2n minus 1 has only correlation with z2n minus 1 or z2n minus 2. And thus z2n minus 1 has only one correlation term. And thus the total number of covariance terms or correlation terms is 4 into n minus 1. And thus this summation gets simplified to 4 into n minus 1 into p cube into 1 minus p. Thus variance of t of 1, n is equal to 2n minus 1 into p square into 1 minus p square plus 4 into n minus 1 into p cube into 1 minus p divided by 2n minus 1 whole square. And variance of T2 comma n is pretty easy since it has no covariance terms. All the terms are independent. Thus, the variance becomes p square into 1 minus p square by n. Next, we need to find out the limit. So here is a small mistake. Part C will be from here. Till this, it is part B only. Okay. So limit n tend to infinity, variance of t1 comma n by variance of t2 n. If we just use the limit, it and we simplify, we get it as half into 1 plus 3p by 1 plus p. Now 1 plus 3p divided by 2 plus 2p is definitely less than 1. If we just simplify it, if we just subtract it, 2 plus 2p minus 1 plus 3p, it comes as 1 minus p, and we know that p belongs to 0 comma 1. Thus, this ratio is less than 1. So this is the answer for the second part. And for the third part, since we know that the limiting variance of t1n is less than t2n, hence we will prefer t1n. Hare Krishna.